Today we have begun with our NumPy part, and we did some of the activities there. Okay, now coming back to our PPT, and let us discuss here about some of the things from about the NumPy, starting with an overview of NumPy, and then we will resume with our practicals. Please keep your yesterday's NumPy file ready, where in the end we have compared the NumPy with our list. So these two we compared, and then let's get started with our rest of the things. So a quick recap to the list. We discussed about, let's say, what list is capable of doing and what NumPy is capable of doing. Yesterday we have seen it. One of the importance of the NumPy was about that NumPy is fast. NumPy is fast in computation. This we proved. This we proved with doing the same thing, and that was element by element summation. And we have on one side list doing the same thing, and on the other side we were doing the same question with the numerical Python array. Okay, there is one more example. We have got a distance, and we have on the other side we have got the time. Both have the same shape. Remember, to perform this with the list, we need to ensure that both has a similar shape, distance and time. And then we can do something like this, the mathematical operations over the entire distance by the time. If you will try to do so, it says that unsupported operand types for the list. The same thing, if you will try to do it with the NumPy array, this will give you the output. So let's do this one. And this will be one of the other reasons why NumPy, because NumPy basically looks like a list, but first it is all about the arrays here. It creates multi-dimensional array, and this is really good when it comes to supporting the multi-dimensional array and doing the mathematical operations with them. Whether it is matrix dot product, or we are doing element by element subtraction, division, multiplication, all these things we can do quite easily, and this will be much more faster as compared to your list part. So let's compare this, and let us discuss it in our file. Every time you open a file which you have used earlier, this just you can keep it as a practice. Click on kernel and click on restart and run all the cells, so that all these lines will be computed. Now you can see that yesterday it was showing that the time taken to perform the addition for these many number of data for this two x and y variable, which we generated with the help of range, and then we try to do the iteration over these elements and then try to sum it. When you have compared the time, it was taking near about this many seconds, 0.5 seconds. Whereas the same activity, when you do it in NumPy, it iterates much more faster, and it just takes 0.005 seconds. Let us discuss about the example now, the NumPy part. So you can declare some why NumPy are better than lists. So in order to do so, what we can do is we can simply declare two lists. We can declare here two lists, say distance and time. That's what the example was having. So let's say distance underscore list. This will be equals to, just take some numbers here. So 10, 15, 18, 19, 21. These are all my values. I think this has changed to markdown, I guess. We got here my values, and we can just write here 23. Now after this, we will take here my time list, and then we will perform here the computation between these two. So here, let's say to travel this 10, let's say 10 kilometers are there, it takes near about 30 minutes. Then next takes 47 minutes. The next takes your 55 minutes. Then we have got 19, so 1.21, or maybe 1.1. The next 23 takes 1.3. Remember that whenever you are performing on this, these values should have the similar shape. And now, where the list will fail. So if you will try to, let's say if I wanted to know the speed, how does we can do it? We can just simply write here distance, and we'll divide it by time. If you will try to do so, you will get an error, unsupported operand types. Now, this list has failed. The same thing if you will try to do it through the help of NumPy. So everything will remain as it is. The only difference is that instead of creating a list, this time we'll put them in NumPy array. So it's kind of a typecasting here, the distance. So we can write here NumPy or np.array. np.array. In order to create the NumPy array, how does we pass the elements? As you can see here, we just pass the value as it is in terms of list, but the output will be stored in terms of array. Output will be stored in terms of an array. Now we'll take here a np.array here, and we'll convert the time as also the part of your array. And now if I'll try to do so, we'll get, okay, so some sort of a difference in the shape, 1, 2, 3, 4, 5, 6. Okay. Let's try to do that, 1.5. Let's display the speed here. Let us display the speed here. Just write here print speed. So these are your different speeds which it is presented here. Okay. Now I'm posting this in the chat. First part, compare y NumPy over list. So these type of mathematical operations are possible directly, and you can see the different distances. You can see the different distances here. Now let's create the different types of array here. 1-dimensional, 2-dimensional, 3-dimensional. We discussed enough about comparing both of these. Now let's discuss here about the different types of NumPy array. Next markdown, hopefully you all have completed till here. Just to avoid, there is one suggestion to everybody. If you wanted to ask anything, for the time being, what you can do is you can just change your send to option to host and presenter. What this will do is this will not show up your question to all the participants, and this will not break the flow of the code. So if any participant wanted to check the previous code, they will still able to see it because your questions won't be visible to the to all the participants. So everybody, please change your send to option from all participants to host and presenter so that this will not break the flow of the code which I am pasting in the chat. So I think a very minimum number of questions are coming up. So what you can do is you can simply change your option of host and presenter, send to option to host and presenter, and then send your questions. This is for everybody. Akshay Kumar. If you are not getting the output, this will not gonna solve me. This is not giving me any kind of interpretation that what type of error you are facing. You have to either paste the error, then I could help you, or you just have to explain me more that what you are trying to do and which is not giving you the output. Also, please don't forget to add a print statement here. So that is correct only. I'm also getting the same error. That's the difference between list and NumPy. We are comparing it. If this error is coming up, this is because we are trying to do the operation between the list. So that is okay. If there is no output, then please check if this is code cell or not. There has to be some issue. If the code is not giving you the output, either you have not added any print statement or the cell is not code type, it might be in the markdown type or some other option. And also, those who start the NumPy, the yesterday's file, please ensure that you run all the cells from top to the bottom. This restart and run is important, or maybe you can just run each cell one by one by using shift and enter. And the reason behind why we need to do so is that we should keep on executing all the cells. This is also an important section. That's all. Otherwise, I think this is quite simple. If you will focus, easily you will able to get rid of the error. If anybody is getting the error, you have to paste in the chat. And as I gave you the suggestion, instead of sending it to all participants, please change your send to option to host and presenter so that it won't be breaking the flow of the code which we are pasting. This could avoid the things. All right, moving to the next part, types of NumPy array. Remember guys, whenever you are starting the code next day, you open this file next day, then these are not getting executed automatically. You have to run from the top to the bottom first, and then you continue writing the new code which I'll be pasting in the chat. All right. So, and if you are getting the error in this part, distance list divided by time list, then that is okay, because here we are trying to compare why list is not good option when it comes to performing the mathematical operations, and that's why we require NumPy. Along with that, NumPy provides us the availability of different dimensionality of the data. So you cannot just only create one dimensional array which we have already defined, but apart from that you also can define two-dimensional array, three-dimensional array as well. So let's get started with our one-dimensional array here. Okay, so let's get started here. Just give me a minute. Yeah. array underscore 1, sorry, array underscore 1. First will be np.array. We will be creating here a single dimensional array that we can simply create it with the help of passing the values here. So this was an example of an n dimensional array. I'll just copy paste the same value. This is your 1D array. So how does we create a one dimensional array first? Okay, next is 2D array. Now this we have already checked yesterday. Next is 2D array, so array underscore 2. In spite of adding up the value one time, we need to repeat it. We need to repeat it twice. Now I'll just add here values starting with 0, 1, 2, 3, 4, 5. And for the second value, we'll also add here 10, 11, 12, 13, 14. These are all my values here. 10, 11, 12, 13, 14. 5 elements are there. Sorry, 6 elements we require. 14 and we require 15 here. Okay. Now let's print here array 2. Let's print here array underscore 2 and that's the value. So array underscore 2 dot shape, and this will provide me the number of rows and number of columns. So my shape will be equals to rows comma columns, rows comma columns. Now this time you can see that the shape is 2. Earlier when we did the same thing, you saw that the dimensionality part here, or in spite, let me show you, the shape was showing only one value, right? This shape here returns in tuple form, and they were particularly targeting to return you only the specific value, that it was just showing you one dimensionality here, as that was your one dimensional data. Now if you will look at here into two dimensional, you will see the values are represented in this way. Now let's take how to create a float type data. Now I have not discussed here how to change the data type, right? Like by default, this array data, array 2 is taking the data type, sorry, d type as integer 32. This is taking integer 32. So how about if I wanted to modify the shape? I wanted to just change the shape here. Sorry, I wanted to change the data type. Okay. Let me paste the codes now. So all the participants start working. Quite a simple steps. You can even type them. Shape, data type. Execute them one by one. Execute them one by one. Okay. Now in this case, once you have finished running them, see that in this case we will require one thing called as dimension, right? We'll be looking for dimensionality here in this case. So how to check the dimensionality, if it is a 2D or not? How to check if it is a 2D dimension or not? So for that we will write here array underscore 2 dot, we will just take here the another of we will just take here the ndim, number of dimensionality, and it shows here 2, shows here 2. Shubham, you have not listened to what instruction I've been saying repeatedly. I mean, you can watch the recording how many times this instruction has I've been given. Anyway, pay attention. If you are getting the error NumPy not found, that means you have not executed the line number 1 to line number end. That's the reason. Whenever, and please note down, everybody, please note down this one. I have repeated this thing yesterday, again today I'm repeating it, that whenever you open the file which you have closed yesterday, you reopen it, these files, these lines need to get re-executed. Understood, everybody? This thing you please note down, that when you open this Jupyter notebook, this will show you the output, but this is your yesterday's output. This is your yesterday's output. This is not today's output if you open it. This is the Jupyter's property, that it will show you the output, that what you did, what you executed, and what is the output that you are getting. So what you will do is you will simply go to the kernel and you will click on restart or run all, or you will start running from the line number 1. Line number 1 to line number end, you will run them, you will execute it till the end. And then you will not get this type of issue like NumPy not found, or this not found, or this type of variable is not working, etc., etc. This thing you have to always do. That next week also, if you will start, if I'll be requiring Python file, or if I'll be requiring NumPy, so I need to first open it and then I need to run it once again. So this part you have to note down in your mind, that these Jupyter outputs which you are seeing, this will not solve you the things. So this is all about everything here. Saying that, okay, let me show you. Wait a second. Just a minute, I'll show you. If anybody is using, let me show you the same options through your, just a minute. Just give me a minute, participants. There also you'll be having, just a second. The interface is same only. Takes a lot of time to log in. Anyway, I'll come back to this part, I'll show you. Somebody wanted to see that where these things are there in the lab, right? So you might be using the lab. If you are using the lab, please ensure that you shut down after your work is over, okay? Otherwise, your hours will be, the clock will be keep on ticking. You can see that we are having only 50 hours given, okay? So this looks like a small number, but suppose if you forget to shut down, sorry, this looks like a big number of hours, but if you will forget to shut down, then obviously in one day, it will be, the clock will reach to the 24 hours. Yeah, I was showing you this part. So let's check. In this case, here is a kernel, and here is your option of restart and run all the cells. Okay, same thing is there. There is no difference. Got it? So this is the same thing which will be particularly restarting the kernel and run the cells. And anyway, to execute the cell, you have this play button, or shift plus enter is a shortcut. So if you open any file and you wanted to execute it, then you can simply execute it with the help of shift plus enter. This will be the same thing in this part, whether you're working in here. And also those who are working on this part, you can just make it full screen as well, okay? So that you can get a lot of things here, and then you can switch the screen between this and the video part. So that will also help you. Okay. This is the shutdown part, which is important after your work is over. Work means after today's session, okay? Maybe the session is over, then you can click on shutdown. This will shut down your lab. All right, continue here. Hopefully everybody has completed till now. And you're most welcome. Let's get started. Let's get started here to the dimension part here. Dimensionality is done. Okay, indexing. Tell me what will be the, just a minute guys. Suppose I wanted to access this part. So what will be the criteria this time? This is a 2D array, right? This is a 2D array. So if I wanted to do the indexing for this particular part, this 15 I wanted to display, that's my target. I wanted to access this. So what should be the position for this indexing? How does we can reach and display this 15 part? So how does we do it? So this is a two-dimensional. So what you will do is you will just write here first. Now this is my value. What I'll write here, 0 or 1? I'll write here 1. So you will write here 1. Remember, if you are sending any response, Mr. Roshan and all the participants, please, I'll request everybody to change your send to option from all participants to host and presenter. That will be much better because that will not break the flow of the codes. Only your chat will be visible, so others will not able to see it, and that will not interrupt the flow of the codes that we are sending, that I am sending. Okay. Otherwise, those who are joining late, they might not able to see the flow of the chats anyhow. Or anyway, so this is one. One will be giving you the last value. Then how to access the 5 value? So for this, you said that I need to write here the value. Index position again start from 0, 0, 1, 2, 3, 4, and this will be 5. So if I'll write here 5, I should get 15, and that's what we are getting. Now we are getting here 2 values like this. Getting here 2 values like this. Okay. One more. Alternative method. Alternative method of indexing of 2D array. Indexing with 2D array. This is your last row, right? This is your last row, and this is the last element in this row, correct? So in spite of doing this one method that we have already did, we can write here, let's say 1 comma 5. If I'll write 1 comma 5, that will also do the same thing, 1 comma 5. Or the alternative method could be, what could be the alternative method? How to access the last row or last column? Remember the alternative method in backward indexing. So if I have to apply the backward indexing, how does we do it? -1, and this will be -1, correct? Because this is the last element in this, and this is the last, this entire row is the last row. So last row -1 and last element in this will be again -1. So that's why -1 comma -1. This will also do the same thing. This will also do the same thing. Okay. So how does we write? First, remember explanation. First -1 is for last row, and second -1 is for last column. Okay. So this will be interesting. Keep this -1 thing. So three different ways of doing it. Next, suppose I wanted to update any value. If I wanted to update any value, update the existing data in 2D array. So how to do it? I have to play around with these index positions here, okay? Suppose I wanted to update 12. If I wanted to do it, I wanted to update here 12. So how to access it? How to update this 12? So I can simply use the indexing part again to update the value. So array underscore 2. What will be the position of this? What will be the position of 12? Everybody give your responses, and while giving the responses, please change your send to option to all participants from all participants to host and presenter. Everybody change your option to host and presenter and send your answer. What should be the value for this one? Give me the exact index value for 12. Exact index position for 12. So this is one index position and the counting begins from 0. So if somebody is writing 2 comma 3, that's still wrong. This is not 2, this will be 1. The counting begins from 0. This is your 0 row, this is your first row, 1 row. So this is your last element here, 12, and we write like this 1. When you will write 1, you will be able to see all your values, and now you can put a comma in between. And what will be the position for 12? 0, 1, 2. So you can write here 2. This will give you the values, and that's how it will be updated. Now let's update your value. The new value will be, let's say, 33. Let us update this with the new value with 33, and here is your next output. And this is the way to update your values. This is the way to update your values. So indexing is not only about fetching the data, but this could be also helpful in updating the existing data, replacing it with the next value, etc. Okay. Now the next part is, I suppose I wanted to take the last 3 elements in the first row. I wanted to display the last 3 elements. Last 3 element of this, what should be the value? 0, comma minus 3, correct. 0, comma minus 3 will give you the value. Okay. This is fine. We can write in this case 0, comma minus 3, colon. This will give me the last 3 elements. But what about if I wanted to display here the value in this form? Let's say, for example, I wanted to check here. Okay. First element will be unchanged. This will go as it is. Now I'll write here position number 3. What we are getting here? What this is basically giving us? This and this. So this is the way to access columns. Imagine that these are your column values and we are accessing them. So display third column values. Okay. When you write colon, this means that colon means this is the colon value. So this indicates all rows. And after this, if you will write colon, this will mean all columns. But I don't want all rows, all columns. I want both the rows, but column I want only specific position F3. So you can actually write like this as well, colon, comma, column. This indicates first colon as row and second column is for columns. So all rows, all columns. Now in spite of writing colon here, I can write the position, which will be 3. This will be displaying your third column value. And colon means all rows. This will show you all the rows. So hopefully you have understood. Excuse me. So what happens here is that we are particularly displaying here my third columns. Sorry, fourth column. Yes, correct. This will be fourth column, not third column, because we have written here 4, 3. Yes, correct. This will be fourth column. Okay. So that's how your first slicing works here. Now let us create here my more dimensionality, like 3D dimension. You can create a 3-dimensional value here similar to this. So let's talk about that, how to create the different shapes. 3-dimensional array. Three-dimensional. Three-dimensional array. So let's get started with my 3-dimensional array part. Starting with my array here. I'll pick my value, array underscore 3, and we can take my values. Starting with my array underscore 3, and we can add here my array underscore 3 again. And let us add the values 1, 2, and then we will take here my values, which will be presented in this way, square brackets, and let's put the value of 6, 7, 8, 9, 11. You can also provide any negative values as well. This can take negative values as well. 3, 5. Let's check the shape. 6 entries should be there. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay. So this is not your one-dimensional. Okay. This is sorry. This is not a 3-dimensional. If you will check the dimensionality of this, or in fact you will check the shape, this will show you 3 rows and 6 columns. This is 3 rows, 6 columns. That is how you can just understand it. To add a z-axis, this is all about only x-axis and y-axis values. So it's like a matrix that we created. Now, to create a 3-dimensional, that means you need to repeat these multiple matrices once again. You need to repeat here the multiple matrices once again. Now let's add the value here, 1, and in the end. Similarly, you can create more and more dimensionality here. 3 means you'll be having more dimensionality. You can see 3, 6, 3, 3, 6. That's what your values are. So x-axis, y-axis, and the third dimensionality is indicating your z-axis. Alright. So x-axis, y-axis value, and 3-axis will be your length and axes. 3 axes are there in this. That's your shape of one matrix, and in such a way that we are having our third matrix as well. We are having our 3 such matrices. We are having 3 such matrices. So I'll send you this value. I'll just keep the same number. Let's not change the numbers here. And similarly, you can create your other dimensionalities as well. So what is your dimensionality? You need to take care of that part. Okay. Now for other values, let's say I wanted to create more and more dimensionality value. Pasted it, I guess. Just now I pasted. Where did it went? 3D array, just now I pasted. You can copy it. The same. Okay. Now there are certain methods here, certain values are there, like arrange function is there, reshape functions is there. So that will that will be used, that could be also used to create your arrays here, and we'll discuss about them as we'll move ahead. We'll discuss about these as we'll move ahead. So that is about how to create your different n-dimensional arrays here. And remember that each value will be an axis here. Each matrix is representing your axis, and this particular part is called as a vector. This one value is called as a vector. This is your x-axis and y-axis here. This is your x-axis and y-axis. This one value, if you have got 1D array, that is called as vector. This is called as matrix. Matrix is represented as a 2D array with x-axis and y-axis value, and your three-dimensional array will be called as your three axes x, y, and z coordinates. Okay, and remember the shape of this is 3 cross 6. The shape of matrix is 3 cross 6. This is your number of this is your coordinates. This is representing for your z-axis. The x-axis, y-axis values are represented in your 3, 6 part. Next. So you can check the dimensionality now. NDim. Sorry, NDim. You'll see that it is 3. You'll see that it is a 3. One value represents your rank. The rest two represents your shape, where in this case you will be having the value as your rows and columns, and your rank, row, column, and rank. Row, column, rank. Okay, so let's write here. So everybody write to avoid any confusion. That we'll have a rank here first, then we'll have number of rows, and we will be having number of columns. Alright, so you'll write here rank, rows, and columns. That's what these represents. You can add here in the shape part to avoid any confusion. Okay, so just to give you an idea about, this is what happens in your 2 rows, 3 columns, and 2 rank. Rank will be represented as the first element, and rest always your number of rows and number of columns. Now this is something, basically it should have been 2, 2, 3. It is showing you in terms of 2, 3, 2. This is particularly represented, not the shape what we are getting in the output. So don't get confused. Okay, next is these are some of the examples. Size, we have size. Okay, size function basically nothing is, but is particularly will show you the number of, what exactly the size of this number of elements. So number of element will be representing your, this is your ND array is one of the other method that shows the number of elements which is present in ND array. Number of elements present in ND array. Number of elements present in ND array. That's what represented here as array underscore 3 dot size. Okay, data type part we can try to transform here. Okay, let's try to check here. I'm just comparing it. We are done with all these parts. Hopefully I have understood all these basic operations here. sorry, basic inbuilt methods. Now let's try to understand some of the basic operations that we can apply to our existing data and some of the functions. Now everybody, those who have finished it here, do respond done in the chat. And if you can, in case if you got any questions, please post in the chat window. And while doing so, please make sure that your values as send to option has changed to host and presenter. Everybody is finished till here? Okay. No, rank 3 is not important. You can, rank is representing your how many number of matrices are there. In 3-dimensional, you can have rank equals to 4 as well. That is also fine. Now your rank has changed from 3 to 4. 54 elements is counting all these values. But how many values are there in each shape? You can just multiply these. What was the original value? Just multiply it. You'll get 54. That's your total number of elements. The easy way to multiply the shape. That will give you the size. Any other questions? Post your questions in the chat privately so that I can answer. So a number of 54 element is coming up with the help of multiplying all these shapes. That will give you the value. And one question was, is 3-dimension, for 3-dimension, 3 matrices are common? No, it is not. It depends upon how many matrices are there. The number of matrices that you will add, the number of matrices that you will add in this will repeat the number of elements that you will add in this, your shape will change accordingly. So now your rank is 4. In this case, the value is 4 now. And number of elements will be 72. Number of element is 72 now. Okay, so size is basically multiplication of these 3 values. These 3 values. Okay, alright, so I think how to display rank. What we are talking about. If you wanted to get the rank here, just take the shape 0. You'll get only rank. Then you will write 1, this will give you the rows. And if you will write 2 here, you will get the columns. And if you don't write anything, that will give you the... Now, just you need to observe here. That's where you need to think of apply the Python rule again. What is the outcome here? It is tuple. So same indexing will be used here. Same indexing part. That you will change your shape. If you wanted, this is your rank part, so you can just write shape 0. If you will write shape 0, you will see 4. That's your rank. Then you will change your value to 1. This will give you the shape here. You will write here 2. You'll get the shape here. So that's how the values work. Hopefully I've understood how to get all these values. Next is my setting the array elements. Next part is my a change. I wanted to discuss about the data type part. Modify the data type. So by default, these are all the data type which it is taking. By default, the data type which is available to us, they are all float data type. They're all float data type. Okay, so let's create a new fresh array. Array underscore 4, which will be equals to, I'll just take here the value, let's say NumPy np.array, and we will pass here the value. So let's say any value I'll pass 11, 23, 34, 45, 56, 67, and 78. These are all my values. All right. Now, right now, my array 4 is by default of integer type. Correct? How about if I wanted to replace this with a float value? What is the data type of this? I can check it with the help of D type. So this returns you that it is integer 32. Correct? Now I wanted to update this particular position. So everybody try it by your own. Update this 23 with a float value. Any float value like 11.987654321 like that. So just update this 23 with any other value. What will happen? So hopefully you might have updated it. If you will see the result, it will take only the integer position. Yes, that's correct. If you will try to update, let's say I was trying to update this 23. So I'll write the index position of this, that is 1. And this 1 will be equals to 11.98453. That's my value. And now I'll take my print of array underscore 4. When I'll try to update, what happened here, that my 34 value, sorry, my value 23 got updated with only 11. Only the integer part will be updated. And the reason is because my data type was integer 32. So assigning float to integer 32 array, it will truncate decimal part. Only integer part will be added. So that's an important thing to know. And you can notice it that if you will try to update any value, it will not work. If you will try to update a decimal value, it will not work. And that's why we need to learn about how to change the data type. How to change the data type. How to change the data type. Now let me share you the code from this line at the top. Compare the data type, which is right now integer. If you will try to update a float value into your integer data type, the decimal part will be truncated. Truncate means it will be eliminated and only integer part will be added to your data. Change the data type of NumPy array. So how does we do it? We do it with the help of simple, let's say my array underscore 5 will be equals to array underscore 4 dot as type, and I'll write here my data type. As type is the function. Either you, while creating the array, you can add something like d type equals to, and you can pass here the argument. That is one way of doing it. Or if you have already declared, then you have to use the as a type function to modify the data type. Now this will do our work. I created and updated in this variable called as array5, and I'll just write here d type. So now you can check that this is converted to the 32, and now I'll compare to update the value. So let us print here my array underscore 5. This will give me all the integers, and let's repeat the same thing. The only change will be that this time I'll use the variable array underscore 5. So first one failed, the second one will not. So original data is here, and now you can see the decimal part got added successfully. Whatever the value you have added, that will be updated. Okay, let me share it first. This change the data type, and then compare the data, then display the data type, and then update the data type. Sorry, update the data into this array. Okay. Suppose you wanted to create an array and you wanted to fill with you wanted to fill with one common value. Alright, so how does we do it? And what are the different data types of float that is available to us? So the different type of data types which is available in float is float 16. This will be the minimum value. These are all different sizes. So according to the size of the data you can update. Float 16, float 32, and maximum is float 64. So these are your three different sizes which are available in your data. And now I'll try to create here an empty array. So let's say array underscore 1. Now I'll update it. Array 1. And np.empty function is there which particularly take the shape, and according to the shape of the value, according to the shape, it will create a array which will be filled with. So I'll write here 6, and I'll just add here my d type. Data type will be equals to float 32. Now by default is float 32. If you will take float 16, that is also permissible. But in this case, then your size limit will be there. Obviously, will be reduced. Now you see that these are all buffer values. You will might be saying that what is this empty is doing here. So if you will execute, these are all buffer values. These are all your buffer values. So you can ignore it. These are all coming up as a buffer value. Let's say if I'll just check it as array underscore 6. So you can say still that it remains as it is. No update. So this is my 6 indicates the size of the array. 6 is your size of the array. Okay. Once we have created an array here, now we'll fill with we'll be filling up here some our own value. Okay. If you wanted to fill only one value in this, the best way is to use a fill function, which will particularly take a value from you. Let's say you wanted to fill minus 7.2345. So what will happen that in this case, all your values will be updated. And if you will see the value, if you will just print this array, you will just print this array here, it will be updating, it will get updated with minus 7.23. These all values will get updated with 7.23. So this particular part is about correct method of how to create your empty array and fill constant value constant value. So fill function is used to fill the value into your empty array. Fill function is used for filling the value into this empty array. Okay. In spite of using np.empty, if you wanted to create a array data and you wanted to fill it with a value here, so the alternative method could be like you can create an array, let's say an array here, and you can just provide here some dummy values. Just you can take here some dummy values here, and you can add them one by one. So in this case, even if you will add some integer in between, even if you will add some integer, that will also get converted into the decimal only, that you can see in this case. 120 dot. 120 dot means this is also decimal, this is also float, this is also float. So even if you will pass an integer data type in a data type of float data type of array, that will be automatically get typecasted while creating it. Okay. Next, array slicing. NumPy array. These empty values are buffer values. When we create an empty array in of numerical type, this will be filled with some buffer values. So these are just indicating your buffer values, which will be replaced automatically as soon as you will add a new value. You will add a value here. So accordingly, it will change. Buffer value will be, let's say, some, which is available in memory and data space. Done? All right. So these will be just your data that we created here. So rather than empty, in this case, we can also create, I'll discuss it, how to create zeros array and ones array, these type of different arrays, the identity matrix, those will be discussed. So if you wanted to, create an empty array, in spite of using np.empty, you can actually use np.zeros, which will be particularly declaring your array, initializing each position with a zero. So that could be one particular thing that you can keep in mind. Okay. Talking about the NumPy array slicing, let's discuss that. And here I will be discussing about one important function, array_3, and this will be given by np.arrange. np.arrange. Arrange function takes your shape 0 cross 36, and this will also take your value range. First will be your value range that we have taken 0 cross 36, and then we need to reshape this. Then we need to take the reshape here, which will be 6 cross 6. This will be reshaped to 6 cross 6. So what is the range of the data that we have taken? 0 to 36. So the value will go from 0 to 35, and this I wanted to reshape it into 6 cross 6. Now suppose I wanted to change it to 6 cross 7, then it will say that no, the total size that it can take is 0 to 35, that is total 36 elements it can take. So you cannot create from this 36 a shape of 6 cross 7, because if you will multiply it, it will exceed 36 value, right? 36 entries. So either you will take 6 cross 5, that will be also not possible, because 30 elements, it is how much element it is? 36 elements. So this 36 elements could be reshaped to, now let me show you, this is the total 36 elements, 0 to 35. When you do the np.arrange. Now this needs to be arranged in a shape which is acceptable. Okay, so what could be the other shapes? You need to think of it. One shape could be 6 cross 6, that is the multiplication of 36. So other shape could be what? You need to remember that you have to create a shape which will return you 36. So one shape could be, yes, it means you guys have understood here. So one shape is 6 cross 6. That means total number of element is 36. Now you need to look for the multiples of this 36 value. You need to arrange them in such a way. So 12 cross 3, yes, that is formidable. So 12 rows, 3 columns. This is passed. You can have 36 cross 1. Then you can have 12 cross 32, 3 cross. Multiply to get a value which should return you 36. So 4 cross 9 could be one shape. 9 cross 4 could be one shape. This is also possible. 4 cross 9 or 9 cross 4. Both are possible. So reshape function reshapes your existing elements into higher dimensionality, but at the same time it will take care that all your elements are the shape, the original element shape will not change. So the original shape was what? 36. So according to that you can make these changes. Alright. So I'll just keep it at 6 cross 6. Hopefully I've understood this, but how the shape is taking, how the shape is working. As I can see, all your responses. So different arrangements are possible here in the reshape. Okay. Now how to access how we need to access the value here. I wanted to access the value. So suppose I wanted to access here the third row here, and in the third row I wanted to access 14, 15, 16. That's your question. Do the slicing in such a way that I will be only getting 14, 15, 16 out of these entire elements. I'm interested in getting 14, 15 and 16. So what should I write? Give your answers in the chat. Let me see if you have understood the slicing part or not. Send your answers in the chat. 14, 15, 16 I wanted to display. Okay, let's start the counting now. I have got many responses here, so quite a simple one. First, what will be the index position for this row? 0, 1, 2. So 2 is there. When you write 2, we'll get 12, 13, 14. Now, I was saying that I was interested in getting 14, 15, 16. So this will be position 0, 1, and this will be 2. So we'll write here 2 colon 5. So that will give me the value. That's how this slicing works. Looks like most of you have given the correct answer. So this is fine. So here the slicing will work in exactly in the same way, just like your standard Python works, just like your standard Python. Alternative could be in the negative value as well. Alternative could be in the negative value as well. I've sent you the response in the chat, so you can particularly take it. You can either alternative could be you can take the value in negative as well. So that could be also there. Next part is reversing an array vector. Reversing an array vector. So the same Python rule. In order to reverse, we have discussed about the step. Right now we have just used only two values, right? Rows and column. Remember that in this case also there is one thing which is called as your step part. So slicing is exactly the way we have learned in our Python. So if my question will be how to reverse an array, so answer will be same. Let's do it. How to do the reverse of array? Reverse an array vector. Reverse an array vector. Array underscore 4 equals to np dot arrange and pass here 50. Let's do the print here. Array underscore 4. So got here my value starting from 0 to 50, 49. 0 to 49. Okay. Now we will use here -1 rule. -1 at step position, right? -1 at a step position reverse the NumPy array just like your standard Python rule. So you can take here array underscore 4. This will be equals to, we will just take it here as like this colon colon -1. So this will reverse the thing. Sorry, comma is not required. That's your value here, colon colon and -1. This will reverse your detail, reverse your array. This will reverse your array. This will reverse your array. Next is alternative method. Next is your alternative method of reversing the array. To reverse an array. Now I wanted to generate here numbers, but let us reduce the size. I'll just take it. Let's say I wanted to generate here 10 numbers. Just print here my array 5. So array 5 will be there. Alternative method. Okay, 0 to 9. Now let's do the reverse by the help of reversed underscore array. This will be equals to np dot flip. There is a function here flip ud, and in this flip ud you will pass your array 5, and that will do your reverse part. Print reversed array. So this is your alternative method. This is your alternative method. So reversing the array, first position becomes last and last position becomes 1. There are two ways of doing it. This is your Python thing. We already explained this part when we were taking the Python. Same thing. Everybody complete this part. All of you complete this all part here. All of you complete it and respond in the chat. If you have finished till here. Okay. There was a question here regarding this flip when you see the options here. Right now it is, okay, wait a second, let me show you. So either you write this -1 or you write flip UD or you write flip. All three will give you the same result. But as soon as you will change, so flip UD, flip the array in up-down direction. Let's create an array here to understand this. Let us say this is my array here. We need a two-dimensional array sometimes. Let's say this is my array underscore 6. Flip till Philip we have taken. Now suppose you will take here in this case array underscore 6 and you will do here dot flip UD not like this, NumPy np dot flip UD and we'll pass here array 6. So what happened here? This has basically made your in two-dimensional flip UD will make your array upside down direction. That means the values has reversed here in each particular array. In each particular array inside this has reversed. Alright? And this is now an upside down array. So flip array, remember, flip array, just flip the array in up down. This will do your up down direction. That's what the explanation for the flip UD. In case of 1D array, this will be particularly reversing the things. But here in this array form, you can see that it is up down. How to get the predefined method? That's pretty simple. You will use np dot and press tab. All your options will be available here. Multiple options are there, but we don't have to do all these different options. We don't have to try all these. Only few methods are important. Like this is one important thing. Suppose you wanted to do your the first element, you wanted to make it as last. So remember, this is gonna be the point that we are reversing, but we are particularly reversing here all your value. Not press enter, tab, tab. This we have discussed in Python as well. In Python also I discussed the same thing. Dot and after that we write tab. Please start making the notes, guys. I'm feeling that you guys are asking the same question so many times, which I have already answered. So try to make notes. You have to learn it like a student. You can't keep each and everything. So make small notes. That will be really helpful for learning purposes. And that will improve your confidence. When you write the things, it goes, there is some coordination is there. Better learning coordinations will be there. So try to type somewhere, try to create some short notes when I explain anything. So you can easily recall those things when it comes. So what I was saying is that till here it is fine. I'm just sending the code here. Execute it. And that's how you can understand your flip UD part. Next, in this, if you will change here np dot flip R. What happened here in this flip part is that, okay, it presents the value in such a way that your this particular element has changed its position. Okay, so particularly this will particularly make your data reverse the order of each and every element along your axis. So left will become right, right will become left. That's what the flip R does. Flip LR, sorry. LR means left and right. UD means up and down. So flip LR means reverse. This will reverse the order of elements along axis 1. That is left, right. Left, right. LR means left, right. So in this case, you can see that your values will be flipped. Within this entire value will be flipped. And flip LR will be particularly targeting only the elements. So both have different purposes. Alright? Both will be doing the different things. LR will do the left and right for every element present in the array, whereas UD will be doing your up and down. So the last element of the array will become the first element and the first becomes the last. So this is your UD. Okay, so hopefully now you have understood the LR part. These are all very important functions when you will do complex work. There, this particular thing will be really helpful to you all. Now, can you guys try to attempt? Can you guys try to attempt doing the same, both the things? Do up, down, and left, right. How does we can do it? Yes, Roshan. Yes, Mr. Roshan. Your answer is absolutely correct. And rest all, you try it. How does we can apply both the things? That means we reverse the order of the element. At the same time, we wanted to make your data, make your elements of this array up and down. So how does we can do that? Send your responses in the chat, and while sending it, make sure that you have changed your value. Send to option 2, host and presenter. Quite a simple answer. Just apply some logic here. One of the simplest thing here. Try it in your Jupyter notebook and then check that whether you are getting the desired result or not. My desired result is that my 35 should come at this position, and here 5 will be at this position. So particularly I want both the values. I want LR as well as UD in both. So apply it and send your answer in the chat. Apply into your data set and then send me your answer in the chat. Apply it and send your answers in the chat. Meanwhile, I'll refresh my kernel, restart, run all. Let's get started. So one option could be that you can particularly do in this way. So I'll discuss both the options. np.flip, and in this case you can apply directly np.flip ud, and inside this you can write np.flip lr. This will do your work. Both are applied. Next is the simple one will be np.flip, and in this you can take your value. What was your value here? Array underscore 6. This is also fine. That's your alternative method. This is your alternative method. So either you apply two functions or you apply it with using np.flip. Many of you have given both the answers. So that's correct. You might have tried. So this is what our results were when it comes to reversing an array vector. When it is 2D, when it is 1D, both have different approaches. Next. So I've sent you the code. Already I have sent you the code, and I've checked that many of you have already sent the correct responses. Looks like you have already understood it. And if not, then you have all these codes in your screen, in your chat as well. You can try them and you can finish this one more topic. Next topic I'll be starting with array creation function. So how to create different arrays using your different functions which are provided to us by the NumPy. Like I wanted to create identity matrix, I wanted to create an empty matrix, I wanted to create zero matrix, I wanted to create one matrix. So how does we take it? By the help of different options. So let's discuss this. Transpose is particularly related to transport method is also there, transpose is also there, but transpose will change the shape, right? Because in that case, what will happen? Your row will be changed to column, and column will change the column value will be changed to the row. Transpose is a different way of it will be particularly reshaping your array. It has nothing to do with the flipping of the data, right? Flip is basically just changing the value, but if you wanted to just transpose it, then it's like reshaping the data. So that part will also come back when we'll be doing some maths, some sort of a multiplication, like matrix multiplication. There it will make sense to us why transpose will be important and how does we can use it. So wait for that part. Meanwhile, let's see the different functions which NumPy offers us. Array create function. Let us start with few of the inbuilt method, few of the functions which are available to us. np.ones are there. Using the np.ones, we have to take the values 3 cross 6. That's my shape, 3 cross 6. And here we will take my data type. The data type will be equals to float 32. You can just take your value, okay? Just take your value. The first one is your shape. The second will be your data type. 1 means the value will be filled with 1. The array will be filled with 1. So this will create a NumPy array filled with 1. Shape 3 row. Number of rows are 3 and number of columns are 6 columns. Number of columns are 6. And all the values will be filled with 1. That's the meaning of 1 rows. Sorry, all these are filled with NumPy 1s. Next is np.zeros. You can take the same shape, just change the function. As soon as you will write here zeros, this could be used for initialization of creating a matrix. Especially this could be used for creating sparse matrix. Okay. Sparse matrix is a matrix which is whose most of the elements are 0. Whose most of the elements will be 0. So this could be helpful there. You can take a shape and according to that your values will be changing. Function is straightforward np.zeros and all your values according to the shape will be filled with a 0. Data type will be particularly making sure that your 0 will be either represented as a float. So this dot indicates that this is a float value, and if it is without dot, that means it is an integer value. If it is without dot, that means it is an integer value. Third one. So this was your 1 or 2. Third part is identity matrix. Identity matrix. This is used to generate a n by n identity matrix. You can take the default type as float 64. The default D type is float 64. Take here my identity matrix. What is the meaning of identity matrix? It means that the diagonal value will be 1 and rest all value will be 0. Diagonal value will be 1 and rest all values are 0. Okay, so diagonal values are 0. No, by default it is not float. We have made it as a float. That's why. Just a second. Diagonal values are 1. Non-diagonals are 0. Diagonal values are 1. Non-diagonals are 0. So what we are doing here, we are trying to check the shape. Sorry, we are trying to create an identity matrix, right? So we have to write here identity. Quite an important matrix here. You can save it in some. So NumPy dot identity will provide here the shape. Just provide the shape. Let's say the shape is 7, and there is no need to provide the data type. And even if you will not write any data type, this will be generating a float data type only. These values generate in float data type. If you will specify it as an integer data type, then only it will get converted into integer. That we can do in this way by adding 7 is a shape, and you can take your d type. This will be equals to integer, and the shape would be 8, int 8, and that will be arranging the data into a NumPy identity matrix of shape 7 cross 7. We have taken the shape 7 cross 7, and this is how your identity matrix will be created. Let me send you this. Let me send you all this. We have got our diagonal values. We got here my identity matrix. So these are your diagonal elements. These are all filled with 1. Next is empty and fill function. Next is empty and fill function. Empty and fill. Empty we have already tried, right? Empty we have already taken. Fill function we have also tried. We'll just take it once again. This will be your step number 4, part number 4 of doing the same thing. Array creation function by using your 4th a different type. In spite of this, we can take a different one more hash. Okay, let's do that by using np.empty and provide here 6. So this will be your empty value. Now you can see that empty has generated some other values now. You can see it is coming out to be 33.33. So that was the last element. If you will remember, this was the last time. I mean, this is equals to value which we have created somewhere. So these are all coming up as a buffer value. This is all coming up as a buffer value. That's what the empty. What is important in the empty is that you need to fill it with a different shape. Then only you will be having. Yes, that's correct. int 8 is 8 byte. int 32 will be 32 bytes. So that much size it will be taking up. So this is basically related to the memory allocation. If you don't need that much memory, you can save it by specifying the data type. In spite of just declaring it in the default data type, you can change this data type from 8 to, let's say, 16 if you need more value. If you need know that 8 is enough, so you can reduce the shape. In integer, the sizes are int 8, int 16, int 32, and int 64. In float starts with float 16. Float will not be float 8. Float 16, 32, and 64. Remember this part. This is common in Python as well as in your NumPy as well. Okay, np dot next function empty is there, then full. You'll write here the shape. Let's say 10 is what we wanted to fill, and 10 is the shape, and then you will write here the value. Let's say the value is 6.7. So the shape, and it is filled with your value 6.7. Empty is there. Then 6.7 values are there. Next is fill. After full, the difference between empty and 0 is 0 will be. How does it look like? Same. This is a resultant of empty. This is a resultant of 0. Values are different. If in your case you are getting 0, that doesn't mean that everybody will get a 0. This is a buffer value. MT always gives you the buffer value. You might be getting the 0, others might not get. And this is not a strict rule here. We have already discussed about the MT, so your questions should have come up here. This is the way where we explained already what does the MT does. So MT will be giving you the buffer. If this had been giving the 0, why we have got these type of value in this case? And why not everybody is getting 0? Correct? That asks the questions. What these are coming up in fact is some values which are stored at a memory, and we are getting this as a buffer value from that specific memory position. So whenever you will try to declare it in MT, this will give you some random value. And with MT, no, the buffer means this is basically pointing to some memory, and that specific memory, whatever the value is present, that will be added. That is the meaning of buffer values. The pre-stored values at a memory location, like this. Zero where it is used. Forget about me. I use zeros in my. Guys, where this 0 could be used? Can I have the answer? I mean, I discussed it, so I'll expect some answer. Where this will be 0 matrix will be used? Can I have the answers from participants? One could be initializing the value so that you will not get those buffer values. Okay, next. More than this, there was one more example I said. To create or initialize one more special type of matrix. What was that? Anybody noted it down? Then you can. So identity is a different verb, not transpose, nothing. One utility I just said when I was taking up sparse matrix. That's very good. That was the answer. Sparse matrix. We discussed it. Sparse matrices. What is a sparse matrix is used is that this will be matrices where most of the elements will be 0. So you particularly try to create a shape of a matrix, and then you fill at a specific positions. Only the values will be filled, and most of the elements will be 0 only. So those specific positions, maybe two elements in one row, and that will be like a very huge matrix. That type of matrix is called a sparse matrix. Most of the elements in sparse matrix are 0. So that's where you can create. And second one, if you wanted to create a shape of the matrix and later you wanted to initialize the volume. So with certain default value, if you wanted to initialize a matrix, there also 0 matrix could be really useful in spite of creating an empty one. Now that's the utility. Remember sparse matrix. That's the utility of 0 matrix. If you will do NLP later, there it will be used. This term, sparse matrix, in natural language processing, there it is used. Or maybe you will be using these in creating recommendation engines. There, the terms are there. These type of sparse matrix are created as a data of a matrix between users and rating for recommendation engines. There also the high. I mean, I'm just giving you some use cases. Recommendation engines basically is based upon again the sparse matrix, and the sparse matrix is created between users and rating. So most of the users entry will be 0. Only the few users, I mean, it's like users don't watch all the movies and all the television shows available on a platform. They just watch some specific one. So only those particular value, those ratings will be available, and rest all will be 0. Correct? So that's what the utility could be there on a higher scale. This is pass matrix, and there again we create this 0 matrix part. Okay, next. So hopefully you have understood through these conversation that what are the utilities of these part. Now we have discussed already about the full part. Now I'll replace it with fill. Let us replace here with fill. Now when you will try to do it, fill basically takes a value. Okay, it will take a value, only one value it will take. It says NumPy has no attribute. Wait a second. Yeah, basically NumPy is not having the fill, but you have to declare a variable. Maybe let's create an empty variable. NumPy empty, store the value in array. np.empty. Next was array. Let's take another value. Let's say array 7. This will be equals to np.empty. Now we can take this array value dot fill, and you can provide here the value. Let's say 6.0, and you get an array here, array underscore 7. So that's how we use the fill part. If you wanted to create here. Okay, next could be line space. Next will be len space. Len space. Another function. What does it does? So let's check it. Our fifth function to create an array. Generate an evenly spaced n size will be there, elements, your start and stop, and in this case the stop value will be included. It will be not like a range function where a stop value will be not included in the. It is not an arrange function. Arrange function does not take the last element. This will take the last element as a part of the value. So stop value will be included. And now we will take here the start value. We take here the stop value, and then we take here number of elements. We take here number of elements, and remember these will be all equally spaced. That means the differences will be equal. np dot len space, and you will take here the start value, and I'll take the end value, and I'll write here the number of elements. So they all are equally spaced here. 0 first element, 1 is the last element. The differences are equal in them. The differences are equal. Okay. Depending upon what is the size here, the values will be taken. Let's say if I'll take 11 elements, then 0 is there, 0.1, 0.2, 0.3, 0.4. So you can see that their differences are equal here. Their differences between them are equal. That's called as equally spaced. That's what the len space does. Now again you can take this value, and you can take here dot reshape, and again you can reshape the value. Remember, while reshaping you need to check here that your let's say I'll take here 0, 12. Okay, 12 elements is created, and they're all available in the shape of 4 cross 3. If I'll take 11, then only two type of shapes will be possible: 1 cross 11 or 11 cross 1. right? But with 12, different other combinations are possible. That's why this linspace will make more sense. Next is log space. Sixth part, log space. Sixth part is log space. I'm making it as marked. Just remove it. You all please finish it till here, linspace. Meanwhile, I'll just make some arrangements here. Make it look much more better. Okay, now it is fine. In this case, my first part was np dot once, and second was numpy dot zeros. After the linspace, I'll go for the next part. That is your sixth part here. Log space. Let us generate here. Generate an evenly spaced elements on a log scale between base start and base stop. Default basis, that is particularly talking about the log base. So default log base is 10. That is log 10, log base 10. Default log base is 10. np dot log space. You can take in log 10 as well. That is particularly to take the log value of a number 0, 1, 6, and you can provide here base equals to. You can, if you want base 2, you can provide here base 2. You can provide here log base 10, and that should give you the output here. So accordingly, your data will be changed. Start value is 0. Start value is 0, and end value will be provide here base 10, and accordingly your value will be equally spaced here. Again, they are equally spaced here on a log scale. Total number of elements that we wanted to generate here is 6. Done? Completed everybody? Now I'm giving some question here. I'm giving one question as we have taken already a lot of things. I'm just giving one exercise before we go for the break. Exercise. Everybody will take part here. I'm just giving you one exercise here. And this is about creating a 2D array. 2D array with one on the borders and rest position will be 0. So inside you will have a border of one value. I'll just show you. This is what I want. The output I want in this form. A matrix 1 1 1 1 1 1 1 1 1 1 2 3 4 5. Okay, rest all values will be 0. Border values are 1, but other values will be 0. Depending upon the shape, the number of zeros will be increased. This could be one question here. All right. The other part that I will be requiring, the other question will be, I wanted to create the same question, but this time I wanted to fill the border value with 0. Rest all you can fill it with say 2. Rest all you can fill it with 2. Everybody will use your own logic. Okay, there is no need to do those internet Google thing, right? We are here to learn. So even if you will fail, that is going to be only adding up to your logical understanding. So there is no one will try to do it through the. Obviously, don't search it on the internet. Try to do it by your own. I want the shape of 10 cross 10. The shape of the array will be 10 cross 10. 10 cross 10. So try to do it by your own. Hopefully you have understood the question. In one case, I want all the values will be filled with, all your values will be filled with, the border value will be filled with 1, and in between values are filled with 0. And this one, the border values are filled with 0, and rest all values are filled with 2 or something like this. So apply the logic, think about it, how to do it, both the questions, and we will meet you after the break, and then you can start sending the answers. There is no need to send it right now. Okay, just take your time, and we'll see you after the break to continue to take your questions, to take your answers then. Okay. So I'm starting with the polling activity, and let's go for our break. Then once we'll come back, we'll discuss this question. I'll give you time. When I'll come back, I'll give you time. So you can go for your break. No need to do it right now. And even if you will complete it, no need to send your answers in the chat right now. We will discuss it after the break. Polling activity is on. We'll see you after the break. Thank you. Start the clock after 1 minute. Hello everybody, welcome back. Hello everybody, welcome back after the break. Now, now you can give me the answers. Now give me the. Let's try to continue with our problem. So hopefully everybody is back. Remember that in this question, I can see some weird answers coming up. See, particularly we don't have to use any loops here. Okay, it's all about. And somebody has actually sent me an important one. I'm not going to reveal the name, but full marks to the attempt. But this is not the solution. I mean, this one is just amazing results are there. Some interesting output. I'm not going to reveal the name, and but I mean, this is what I'm not looking for. This one. I mean, this is the answer which definitely I'm not looking for. If I need to declare it, then why I will consider it as a question or as an exercise, right? So obviously not a correct answer, but an interesting output I have got. I mean, interesting response. This is my output we are looking for. I'll wait. I'll give you 5 minutes more. So everybody try it out. These two are your questions in front of you. Try them and give your responses in the chat. If somebody has already given now the basic rule to give the responses is that you will be particularly creating a matrix of 10 cross 10, and you will be using your NumPy value. So create it and try to fill your values. I'll wait for 4 more minutes. Give your responses in the chat regarding the same question. Okay, so now that we have understood all these points, let's go ahead and let's try to give the answer. Let's try to find the answer. So you guys can check. Nice try, Nima. Somebody is giving me answer like first response will be that import NumPy as NP. What will be the second line of the code? I'm interested in that. Anyway, let's go to our next part. Let's find the solution. So apart from the jokes, let's get started. When the question says that you have to create a matrix, then in this case you will be particularly trying to create an answer. So one could be create a np dot ones and the shape 10 cross 10. Display your array 8, pardon. Okay, what I'll do now, I'll try to fetch all these values. Okay, and in this, I will fill a specific value which is called a 0. So how does we can access this? What will be the index position for this one? If I wanted to get the position for this, what will be the index position for this one? We can do it with the help of index 1 cross 1. And what will be the index position for this element? What will be the index position for this one? 9 cross 9. That's your answer. 1 cross 9. 1 cross 9. Fill all these positions with 0. And that becomes your answer. That becomes your answer. Sorry. What happened? Array underscore 8. 1 cross 9. 1 cross 9 equals to 0. And array cross 8. What happened here? And np dot 1. Hey, what? Yes. So that's your one of the answer. I think many of you have. I think few people have tried this answer, apart from those funny answers which we have got. So this is one of the solution that you can use. Now this is not the only way. You can use it your arrange function, and you can try to fill the value. You can try to fill the value. Like I've got one answer here. I'll just try to take it. Array number 10. For me, I will just take it as array 8. Array 8. Array 8. I don't know whether it is a correct answer or not, but I'm just going to try. So it shows, the problem is this one. These all should not be 0. The border area should be filled with 1. So how does we can make a correction here? Okay, so first of all, a range is created. All right, so I think this is not the correct answer. At the first and second line, we have got 1, rest all are 0. So this is not correct. Okay. You can create a 0, you can create an np dot zeros as well. And in that, then you have to particularly target this value. This value. The problem with the np dot 0 is, that in that case, you have to take iteration for this particular value and this particular value. And then you need to take the particular value for these. So basically, in spite of one line, you have to create 3 lines of code in that extra. You can do it, but we have to look for. I mean, what is the developer's way? Developer's way is that we have to take minimum length. The second question, which was their solution, you can calculate it from this again. In spite of having zeros, ones, we can have it as zeros, right? And now, tell me the answer. Everybody calculate it. What should be the answer now? So in between value, I'm leaving empty. Try it now. That's your zeros here. Now please fill the value. These particular value with 2. Fill these value with 2. Fill these value with 2. Fill these values with 2. Write your answer. What should be the index position? Send your answers. This should be this. You guys can do it. Many ways are there. This should be attempted. Either you can do it 1:9, or you can do it in other way. 1:-1. So last element will be not chosen here. 1:-1. Let's fill it with 2. So that will give you the answer. Or you can write in that way 1:9 and 1:9. That will also do the same purpose. So either you write 1:9 or you write 1:-1. 1:-1 will also give you the same answer, and 1:9 will also give you the same answer. That's your result, that's your output. So those who have sent 1 colon minus 1, that is also correct. 1 colon 9 is also correct. Exercise number 2. Let's take some exercises here. Exercise number 2. Checkerboard. Checkerboard. Create 8 by 8 matrix and fill it with 1 and 0 in sequence. And fill it with ones and zeros in sequence. 1 and 0 in sequence. Minus 1 means our last element will be ignored. That's why minus 1 will also work. It will not touch the last element. Whatever you write in the end, that will not be touched in this case. Checkerboard. Alternative 1 and 0. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, that would be the arrangement. The shape of the matrix is 8 cross 8. Checkerboard. Let me give you the explanation, what I am looking for as an answer. This is much more simpler. 1, 0, 1, 0, 1, 0. 1, 0, 1, 0, 1, 0, 1, 0 again. So it will be all filled with 1, 0, 1, 0, 1, 0. Maybe I can just add one more value. An even number will be good because that will change the arrangement. 1, 0, 1, 0, 1, 0, 1. Then again 1, 0. So the sequence will remain as it is. This will be the sequence. Okay, create. Create it. All of you create it. While sending the answer, please ensure that you provide. While sending the answer, please ensure that you send it in private. Don't send it as all participants. Okay, guys, try it. Everybody. Can't see any responses. Same type of answer will be there. Similar type of answer will be there. You have to do the indexing this time and try to fill the value. Okay, guys, so we need to move ahead now. Okay, we have a very limited time. Can't give you this much time here. So if you have tried, it is fine. The answer is again coming up from the same way, just like the way we have created. What you can do is you can simply create an array. Let's say my array is 10. Array 10 equals to np.0, np.zeros, and my shape of this will be 8 cross 8. Okay. Data type. I want the data type to be int8. The reason is that I want all my values to be integer type. And now select every another element. Already we have a 0. Now we need to write the indexing in such a way that we need to particularly select the every another element. Take here every another element by using array 10 1 colon colon 2. This is my every another element colon colon 2 again. This will be filled with 1. This value is filled with 1. Next, I'll change this position colon colon 2 and I'll write here 1 colon colon 2. This will be filled with again 1 and that will do your purpose. So here you need to play around with your step position. Step is 2 means we will skip one value. We'll skip the one value. That means every another element will be filled with 1. And that's what we wanted, to create a sequence of ones and zeros. To create a sequence of ones and zeros. So this is your one arrangement. Now suppose you want a reverse. No, I don't want it to start from 0. I want it to start from 1. So in that case, you will do just one change, and that will be, you'll do np.ones here. np.ones, and wherever 1 is written, you will replace it with 0. So these are your two alternate solutions for the same problem statement. This is your alternative solutions for the same problem statement, two different solutions. We are just taking every another element. What is this one? This particular value is what? This is my normal 0 value. I wanted to take every another element. So what should be the take here? Step should be 2. What was the by default step? When we do the indexing, what is the by default step here? Suppose I wanted to take here colon colon 2. What is the meaning of this colon colon 2 here? That in this case I will be taking the shape is two values, so we have to take it for first rows and second is for columns. So what happens here? This will be particularly giving you, this is particularly fetching every another element. Suppose in case I'll take a matrix, let's say where does I created a matrix? Okay. To understand this, you need to understand this particular thing. What is the meaning of underscore? What is the meaning of 2? The 2 is particularly used for skipping one value at a time. So I'll just add here in this array 3. What was your original array? The original array is this. Now I'm just particularly targeting to take the value 1, 0, then I'll skip 1, I'll take 2, then I'll skip 3, I'll take 4. So when I'll see that I wanted to fetch this value 0, 2, 4, similarly 6, 8, 10. Okay, now in between I wanted to skip this particular column as well. Right, this particular position I will skip again. So as because I have written here 2, so in the row also it will be skipping and in the column part also it will be skipping. So this particular part will be skipped here. What will be the next value? 12, 14, 16, and then this particular value will be skipped again because of 2, then 24, 26, 28. That's how this value has been taken. Now I have a change here because the first value I don't wanted to replace, rather I wanted to select this 1, 3, 5. Now in case you wanted to select 1, 3, 5, you have to just write here 1. That means start positions you have to change now. That's what I did here. So what it will target now? It will target now to take here 6, 8, 10, and similarly you can skip, it will particularly target here 18, 20, 22. Correct? These are all your arrangement. Now let us say I wanted to change here to your this position. So this will particularly target here now 1, 3, 5. So now it is not taking 0. Now it is not taking 0. Correct? If by default you will leave, that means the start position will be this. But if you will make sure that no, I want my start position to be 1, then it will take 1, 3, 5, then 13, 15 and 17, then 25, 27 and 29. So things will change here. It will be shifted by one value. That's how it is working. Just keep this part with you all to understand how these are working. So this is particularly your start position. This is your step. Here the start position is 0. If you will replace it with one more change, and that is 1 colon 2, and I'll take here 0. So you'll get two different values in these two sections. And that's why we need two values, because one will be not more than enough. One will be not enough. Now keep this with this particular part to get your responses to understand it. Okay, starting with my array calculation methods. That's our next part, NumPy array calculation method. We need to start with my NumPy array calculation method. Code is shared. These are your two different answers for the exercise number 2. These are your two different answers for the exercise number 2. Now let's take some universal functions here, which are which will be helping us as our mathematical functions like square root, floor, cos, exponential values. So let's try to take that. Do it fast, guys. We need to finish this and then we need to start with our panels. So after these exercises, you will be these are all done. Let's discuss about some of the other methods. So we have already taken enough exercises here. Okay, this much exercises. This exercises will help you to understand the slicing concept. Like as in Sheena Paul. Let me just check your answer. If you're getting the answer like this, then see there could be many different ways of doing the same thing. You have to look for this particular part I need to know. Okay. Yeah, this is also correct. That's also correct here. This is also correct. No problem. This was from our one of the participants, Sheena Paul. Okay, let's do some array calculation methods here. Let's discuss that. Array calculation method. From my NumPy. So here is my value. Let's get started with my array underscore 10 equals to, sorry, array underscore 11 equals to np dot array, and we'll take here my values 1, 2, 4. Just take any values here 1, 2, 4. Then we can take here values like 4, 5, 6. Just take some dummy entries. Now I wanted to use it, and I wanted to apply here some of the inbuilt universal functions which are there available in my array, NumPy array. So one is sum function. You can also do the summation here through the np dot. Wait a second. You can particularly pass here x's value. This is like sum of all the terms 1 plus 2 plus 4 plus 5 plus 6. That will make it 22. Now, suppose you wanted to do only column wise or row wise, right? So row wise, for that you will write here. Suppose I'll write here x is equals to 0. When you write x is equals to 0, you will get 1 plus 4, 1 plus 4, then 2 plus 5, then 4 plus 6. That's your answer. This is your x is equals to 0. That will particularly be along the 0th axis. This is along the 0th axis. X is equals to 0. X is equals to 0. Next is, if I'll change the axis here, like x is equals to 1, you will see that it will be summed like this. 1 plus 4 plus 1 plus 2 plus 4, 4 plus 5 plus 6. So we have got on one side 7 and the other side is 15. So a new array is calculated when you do x is equals to 1 and x is equals to array. This is your first along first axis, zeroth axis, first axis. Let me share you this code now. This is our array variable number 11. First is your normal summation, which will count all the values. But if you wanted to control it row-wise, column-wise summation, then you can use your axis values, which you can pass inside the sum function. Take the code from the chat. Next is minimum function. Next is minimum function. Minimum method. Oh, wait a second. Just a second, I understood. Here I think it got changed here. Can you see it values now? Let me share the code. Now everybody will able to see the code here. It is all in participants. So I shared all the lines. Just take it. Okay, next. Minimum and maximum value. Hopefully everybody has got the code now. Okay, now let's apply a minimum method. Array underscore 5. Sorry. Array underscore 12. Let us create here now np.array. This was not shared. Exercise number 2 answer. This was somehow like the explanation. This is just an explanation that how you can do it. Array number 11 I have shared it. Array number 12. NumPy array. NumPy array. So I'll just take here a value where again you can do it in this way that you can particularly take all these value a 2D form or 1D form. If you will not provide any axes, if you will not provide the axis, it will give you the overall value. So for example, if I am having this array here, I'll just take my array value and I'll write here array underscore 12 dot min function. So this will give you the minimum of overall. This will give you the minimum of overall. This will take your array of overall. Sorry, minimum of overall. Wait a second. Where is that? Array underscore 5. Yeah, here. There could be array underscore 12 like this as well. And in this case also we can apply array underscore 12 dot min function. Okay. So in this case the response is 0. In this case the response is 2. So you can check the values and accordingly your minimum value will be calculated. This is from the overall all the elements. Now again same rule. You can apply here the axis. Inside this x is equals to, when you write x is equals to 0, it will particularly try to find the minimum value along the axis. It will try to find the minimum value along the axis. You can do it for 0, you can do it for 1, and accordingly the minimum value will be calculated. same rule. Let me just show you the original value of the array so that you can just check. Alright, so when you write x is equals to 1, so it will scan all this value and it will check if the minimum value is 6. Then the next minimum is 6, the first minimum is 0, then second minimum is 6, then 12, then 18, then 24, and then 30. That's the range here. When you write 0, then obviously you'll get this particular value because along this axis, the minimum value is at the first line. So that's how you get it for overall minimum, then minimum along the axes, minimum along the rows, along the columns. You can do it, you can control it with the help of axis equals to 0, axis equals to 1. Okay. One important function, np.argmax. np.argmax function is used for converting in the array into a decimal value. np.argmax. This function is used for converting into decimal value. Decimal value. Okay, there are certain examples I can give you, like in case of multi-class classification, especially when you use deep learning algorithms. There, we convert the data into the classes into zeros and ones combination. So suppose if I'll write here zeros and ones, okay, how does we can write a value 3? It's like suppose my class is 1, 2, 3. These are all my classes. Okay, this is my value here, right? So what this np.argmax does is it particularly check how many number of values are there in terms of zeros and ones, and accordingly it will give you the calculation np.argmax. So suppose if it is filled with 0, 1, and rest all are again 0. Rest all are 0. Okay. The resultant output should be according to this. So let's check. 0, 1. Then I'll write here again 0. Again 0. Then again 0. So 1, 2, 3, 4, 5, and again 0 here, 0. And again one more 0. So 0, 1, 2, 3, 4, 5, 6, 7. This is my value, this is my array value. We can call it as array underscore 13, which will be equals to this. Okay, now let's take here np.argmax. And we will pass here array underscore 13. So this is what our expectation was. We should get here. Okay, let me give you the idea here. This will be arranged as a 0 class. This will be 1 class. This will be 2. This will be 3. This will be 4. This will be 5. This will be 6. So if at this position 1 is found, our reply will be 1. But if this 1 will be shifted here, then output will be 2. Output will be 2. Okay, change your value, change your position. I'll write here 1 dot. What should be the output now? 2. What should be the output now? 2. So basically it is particularly converting all these values in terms of your decimal, and that's your result. The last element will be, so first element is 0, then 1, then 2, then 3, then 4, then 5, 6, 7. So if I write here 1, what is the meaning of this? That at 2 there is 1, so this will be 2 and this will be 7. Answer should be 7 plus 2. We got here 1 at this. I think only one value it is taking np.argmax. And then we can take here consecutive values. What about that? 1 plus. So just taking one value at a time here. np.argmax. So this will be particularly taking the one value. Others will not make sense. That's what I wanted to show you through this. So if you will be having at one position already we have, so you'll get the 6. Now you can make the changes here. Obviously x is equals to 0 and x is equals to 1. Accordingly your things will be definitely changed. So even if you will write multiple values at multiple places, that will not affect your result. This will only take the one value, rest all, whether it is 1 or not, doesn't matter. It will give you the same output. So even if you will have multiple entries, doesn't matter, it will give you the same output. So generally it is used in converting your class into one-hot encoding. In multi-class classification, this is used. Just a use case I'm telling you, in deep learning especially. Okay, so this will be particularly only looking for the value wherever the 1 is found at that specific position. What should be the decimal value? If it is at this position, output will be 0. If it is this position, then output will be 1. So just count it. Just count this value. So it's particularly converting this one-hot encoding result into a decimal value, and this is what the arrangements looks like. So it is whatever the position will have a 1, that particular value will be the output. As simple as that. That's how your np.argmax gives you the output. You have similar to this, we have got arg min as well. Okay, now why we are getting why we are getting the value in terms of decimal value. So particularly you can say that this is basically returning a what? If you will just pay attention, we are getting what as a return, as an output. What is this? 1 is indicating that at this position value is there, but why we are getting the output as 5? Can you tell me? Index, very good. This is returning you the index value along the axis. That's the trick. That it returns indexes of maximum value along axis. So whatever the axis will be there, x is equals to 0, x is equals to 1, according to that your value will be there. I use this example because I know that where this is used. It is used in your multi-class classification to convert your multi-classes into arrangements of 1s and 0s. That is where the utility will be there. In general, you can apply this np.argmax in your maybe another data we can take. Let's say if you wanted to take some data here, where is that? This one. This one was the value here. Okay, so this is my next element. I'll just keep it for array 13 only. Keep it for array 13 here. Let me display the output. So this is your value. Now suppose I wanted to add here 2 to all these elements. If I wanted to add 2, I can write it like this. Or if I wanted to add some like 5 values, that will be added to all the elements. So your value will be automatically updated. So in this case, if I try to apply the same, what will happen? np.argmax np.argmax argument max and pass this value. When you'll pass the value, it will return you the maximum, the index position of the maximum value. Now here definitely the x is equals to 0 and x is equals to 1 will play in a role. So we are getting the index position 555 here when we take x is equals to 0. We are getting, remember, this is the index position for the maximum value. This is the index position along the x is equals to 1 and along the x is equals to 0. In both the positions, our maximum value is present in at index position number 5. So returns index position of the maximum value. Returns index position of maximum or max value along axis. So this could be one more answer, one more try you can take. One more example. Okay, that's the end of your one more function. Let's move ahead to statistical array methods. Next is statistical array method. Statistical array methods. In the statistics or statistical array methods will be particularly related to your average, okay, mean, standard deviation, these type of values now we are trying to calculate along the array, So I'll take this particular value, a dummy array we created at the top. Maybe I'll continue with this example. So take here my array 1. Let's take here 1, 2, 4, 4, 5, 6, or 4, 5, 7. Maybe just take here the value as 5, 6, 7. This is basically returning us the index position. The answer is already written here. It returns the index position of the maximum value. So don't tell me that you don't know the index position. This is 0, 1, 2, 3, 4, 5. That's why we are getting 5 here. These are all getting 5, 5, 5 for the different values of the maximum value along the 0 axis and along the 1 axis. Already written your answer. You can read it. That's our array here, and this is our value. Now from this array, mean value of each column. Again, when you wanted to do it for column wise, you will use x is equals to 0. First of all, if you wanted to find the overall mean value, so what you will do, mean value will be simple. You will take this array underscore 1, what you will write, dot mean. You will just write your dot mean. This will return you the overall mean. This is your overall. That means 1 plus 2 plus 4 plus 5 plus 6 plus 7 divided by 6. This is your overall. But if you wanted to do it along with the x is equals to 0 and along with the x is equals to 1, then that will be particularly your row wise or column wise approaches. In that case, you have to write here x is equals to 0 or x is equals to 1, and accordingly your value will be changed. So like you can see that we are getting 1 plus 5, that is 6. 6 divided by 2, that makes it 3. Similarly, 2 plus 6, that makes it 8. 8 divided by 2, it is 4. 4 plus 7, that makes it 11. 11 divided by 2, that makes it 5.5. So this is how your values are done for the overall, and for your x is equals to 0. Similarly, you can change your axis as x is equals to 1. That will also do the same thing. Okay, by the way, we have got this function in NumPy.array, np.mean as well. And in this case, you have to particularly take this array and you need to pass it as an argument, and then you have to write it as x is equals to 0. You have to take x is equals to 0. That will also give you the result. That will also give you the output. Quite a single line questions are there. Similarly, you can do it along with x is equals to 1. Okay. What about if I wanted to do some weighted average? Next function is average function. But in this case, obviously average and mean will give you the same output. This can be also, average function can also used for calculating weighted average. You can provide the weights, some initial value. Okay, let's take your value here. Give me a minute. So we take here my average, which is used for calculating the weighted average part. Okay. Replace this np.mean by average. First, let's compare what this mean does. Sorry, average actually doing here. So we can write here np.average. This will give you 3, 4, and 5.5 as it is. Now, what I will do is, in this case, we will write here np.average, and we will take here my weighted average now. So in this case, you can provide here weights as a parameter, 1 cross 2. Okay. 1 cross 2, that's the value. Weights will be added here to my value. Suppose you would like to add here 10. So this will not be working. Alright. Suppose I'll go for this particular value, 10. So it is saying that the weights, the length are not compatible. So you need to make sure that when you add a weight, you have to take care of the shape as well. And I'll write here 1 cross 2. This is fine. So these weights will be added as an initialized weight value, and then your weighted average will be calculated. Weighted average will be calculated. Okay, this is related to your weighted arithmetic mean. Okay, and you can particularly call this is called as your weighted average. So some initial weight will be added. Now let's go for the next part, is standard deviation. Next is the standard deviation. Standard deviation measures the deviation of sample from its mean. Now these things will come back again. I mean, if you don't know what is this standard deviation part, then wait for it, because I will be discussing them in depth. We will be discussing them in depth. These are all statistical parts. Weighted average has a mathematical formula. Similarly, standard deviation is also having a mathematical formula. They are applied, and that's how these values are calculated. I'm just using it here so that I can show you these different functions. When I will go to the stats part, the lesson will be, I think, 16 lesson. Sorry, chapter number, what is this one? 4th, 5th. The chapter number 6th part include stats. So there I'll again discuss these sections with mathematical terminologies. Right now you just keep it as a code and just apply it. Standard deviation is also a formula. So we are just applying it to get our results. That's it. We'll take here np.average. This is your weighted average formula is there, which is applicable here, and it is calculating all these three values. Similarly, you can do it for np dot standard deviation, and you have to pass your value array underscore 1, and this will calculate your standard deviation along the axis. So got here my value as 2 to 1.5, that is your standard deviation. Use your mathematical formula of a standard deviation to measure. Weights is just a weight will be added as a weighted average. There is a terminology called as weighted average, just read about it. From the stats it is. The term is weighted arithmetic mean, and it will be like WIXI divided by WI. This is the formula that is getting applied here. This is your weights average. We need to provide here the weight in such a way that this should match with the shape of your array. Okay. So the formula will be something like this: WIXI, which is indicating your weights. In that W is weights, and this will be divided by the weight again. Next is the standard deviation. Standard deviation, I think many of you will be already aware about. So that is what also we are trying to do here. That is what also we are trying to calculate. Variance. Variance will be obviously the square of our standard deviation, or we can say standard deviation is under root of variance. This could be calculated by np dot var. Var is not a variable. Var is for variance. You can provide here the value array underscore 1, and again same axis equals to 0 and axis equals to 1. You can write accordingly. Your variance will be calculated. So standard deviation, variance, then round function. Next is round function. This will round off all your values. So suppose if you have a scenario of a lot of decimal values, if you have got a lot of decimal values, then you can apply this np dot round, and you can pass your array. Or maybe I will just save it as array underscore 2, and I'll pass inside this np dot round. This will round off all your value, and your output will be rounded off. If any value has got greater than 2.5, 1.5 is there, 3.24 is there, 4.5 is there, 3.6 is there. So you have to, if you want the next higher value, you have to write the next value. That means 4.5, greater than 4.5. If it is greater than 4.5, then only it will be increased to fifth value. Otherwise, it will go back to the 4. Right? If you write 4.5, you will get answer as 4. But if you write slightly greater than 5, then you will get answer as 5. That's your variance. That is your variance part. So apply your round function. Alright, so that was all about your different functions which are available to us. Next would be our okay, just give me a second. Now hopefully everybody has completed it. The last section in this case is called as broadcasting. The next part in this case is broadcasting. Next in this case is broadcasting. So is it completed? Can I have a quick yes in the chat? So I'll start with our next and last section. If it is finished, please write done in the chat. One point five will be not rounded off to 2. It will be, so you can see that 3.24 is rounded up to 3. 1.5 is rounded up to 2. 2.5 is rounded up to 2. You have to have a larger value than this. See that you have to write the next higher value, 2.51. Then only it will change to 3. Otherwise, it will remain as it is. Whereas in 1.5, it is not applied. It is weird, but that's how it is. 1.5 is getting rounded up to 2, but 2.5 is not getting rounded up to 3. It is rounded up to 2. You have to take the next higher value, so in spite of that, you can just write like this. So even slightly greater than 5 will be rounded up to 3. That's how it is working. Okay, in the broadcasting part, so I think most of you have given the responses. That's working for everybody. Can I have more done in the chat? Those who have already finished, please write done in the chat to give your responses. Broadcasting part. Broadcasting is about, suppose when you are doing some addition and subtraction, in that case, your array will be arranged in such a way that your array will be broadcasting itself in such a way that it can particularly help you in making your methods or your calculations as a valid calculation in spite of giving your error. Give me a minute. I'll start with our Wait a minute. Okay, so let's get started here with our broadcasting part. That is what I was discussing. So in order to do the broadcasting, let us take the help of the PPTs here. Where is your PPT part? Okay, so let's take it here, the examples. This is transpose. Okay, let me show you through the whiteboard. So broadcasting is basically, it has got certain rules, and accordingly your things will be changing actually. That what you will particularly do is you will take a value. Okay, it will be something like this. Suppose this is your array. One matrix is this, or one array is this one. Let's take an array here. Okay. We have got array number A, which is filled with 0, 10, 20, and one more value. And in this case, it is 30. This is a 2D array. Next matrix will be now I'll provide here the value 1 2 0 1 2. Okay. I will try to add these two values. So the point is these two will be added here. What is the shape of this one? Tell me the shape of this. What is the shape of this? Remember the matrix is only this portion. So accordingly you have to tell me the shape. Only this highlighted region is there, your matrix. This is not your entire value. This particular value are blank. This is not even present. So this is the shape. This is the shape here. Tell me how many number of rows and how many number of columns are there. What should be the shape for this? These columns are not present. They are empty, right? So leave this. Somebody is saying 1 cross 1. Orange. This is the value, the highlighted value. 4 cross 1. Those who are saying 4 cross 3, let me tell you, these parts are not there. Okay. Let us rewrite the things. These are just unnecessary, the confusion over there. Okay. Let me just create it again. Okay. 1, 2, 3, 4. Now tell me the shape. This is your shape here. And this is your shape here. 1, 2, 3, 4. Or maybe I'll just take it as 1, 2, 3. 1, 2, and 3. Tell me the shape. The shape is 4 cross 1 and the shape is second one 1 cross 3. First one has got a 4 cross 1 and the second one has got 1 cross 3. These two are having two different shapes. The question is that whether I will try to multiply them. Will the action will be a will the action will be a correct action? Will particularly will able to do it, or will get the error when we will perform the multiplication or when we will perform the, okay, forget about multiplication. Let's try to do the addition between these two. When we will try to do the addition, will be a correct way of doing it, or it will be a wrong way of doing it? That's the question. Okay, so let's try to do it. Let us try to apply it, the broadcasting rules, and let us try to do the let us try to particularly perform the addition here. Let us try to perform the addition here between A and B. Okay. Let us create here my ones, A, np dot ones, np dot ones, and I'll take a shape. Shape will be cross 4 cross 1. Let us display A. These are all filled with 1 here. This is your array number A. What is the shape in this case? 4 cross 1. Shape equals to 4 cross 1. Next, display A here. Next is B. Next value is B. np dot ones. What should be my new shape? My new shape should be 3, correct? This is my new shape 3. Shape is equals to 3 comma. Okay, all right. Got here my value here. Now once we'll try to do it, once we'll try, we can just write here 3 comma. Okay. First of all, in order to do this one, we need to convert the shape into, when I'll try to do A plus B. When I'll try to do A plus B, I'll get a result. I'll be particularly getting the output. Why we are getting the output in this case? That's where the broadcasting rule is getting applied here. That's what your broadcasting is all about. By the way, the broadcasting rule is that it has to be having at least one of the axes as 1. That's your one of the rule. So maybe you can just reshape this. You can reshape this as 1 cross 3. That's your value, right? And then you will do the A plus B and you will get an answer. So what is going on here? How this is going on? A plus B we are doing here, A plus B. Addition. Similarly, we will try to do it for other values as well. So what is going on in this case is called as broadcasting. What happens in the broadcasting is that these values will be stretching itself to fill the rest of the positions. To fill your rest of the positions while performing the calculations. So what was the shape here? The shape was 4 cross 1 and 3 cross 1. Resultant will be 4 cross 3. So one particular matrix will be stretching itself and it will stretch up to all the 3 values. So the shape will become your 4 cross 3. This is your stretch value. That's why I'm using in different color. And this stretch value will have the same value. So this new matrix will have the same value 0, 0, then 10, then 20, 20, and 30, 30. This is your value which will be stretched. These are your value which will be stretched. So original shape was 4 cross 1. This will further stretch itself to become 4 cross 3. Stretch value will be 4 cross 3. Similarly, we can expand this. This will be also stretched. This will be also stretched. These are also stretched and they will be filled with your values. Again, same value 0, 1, 2. Okay, let me fill it with gray only. 0, 1, 2, 0, 1, 2, 0, 1, 2. This will be the new shape. This will be the new shape. You can call it as 3 cross 3. This is called as broadcasting. There are certain rules for the broadcasting which are there. So when your two different arrays, okay, when you have got two different arrays and when they have different shapes, different dimensionality, they can be combined in the same expression. And here in this case, yeah, 3 cross 4, sorry. Now what happened here is that these had a different dimensionality, but still we have got one thing common between them, and that was 1. So array with a smaller dimension are broadcasted to match the larger array without copying the same data here. Okay. But there are some things which are possible here. So if your two arrays differ in their number of dimension, the shape of the one with a fewer dimension will be padded with ones on its leading side, that is towards the left side, and it will be stretched, and the same value will be repeating. The same value will be repeating. This is your rule number 1, the smaller one. What is the smaller dimensionality in this case? The 1, right? So columns will be stretched in this case your row will be stretched. So the one with a smaller dimension that will be stretched to match the shape. If the shape of the two array does not match in any dimension, the array with a shape equal to 1 in that dimension is stretched to match the other shapes. The two arrays must be compatible here, and their shapes will be agreeing to each other, then only your addition or other mathematical formula will be created. This stretching is coming up from the broadcasting part. This is nothing but this is your broadcasting. Remember the multiplication rule. In case if you don't know the multiplication rule of matrix, though I think maximum of you will be already aware about it. Matrix multiplication rule. What is the matrix multiplication rule here? That number of row of one matrix must be equals to, this should be equals to number of column of other matrix. Then only the matrix multiplication will be valid. Okay. So if the shape is this has got the shape m cross n, and this other has got the shape as n cross mno, or maybe you can take it as p. The row of one is equals to the column of the other. Multiplication will be valid. That's what we need. Okay. So hopefully you have understood the concept of broadcasting here. Broadcasting happens automatically between when you try to do some addition, subtraction between two matrices. This is an inbuilt property of your NumPy array. So let's do the calculations. I'll just take some value here. Markdown part, array broadcasting. So here this will be copying the data here. Let us write array part, array underscore 3. Array underscore 3 will be equals to np dot ones and we'll write here a shape. Let us say the shape is 3 cross 5. Okay, so display it. Definitely, let's display this value. Next is my new shape, my B value. Or maybe we can take here A and B. That could be much more useful. Let's take our next matrix B, which will be equals to np dot ones. And I'll just write here a shape 5 cross. That's it. Nothing is there. This is my B value. Now we will try to apply here between these two. This has got the shape of 5 cross 1. This has got, sorry, 1 cross 5, right? This is 1 cross 5. And this has got the shape of 3 cross 5. One common thing is there between them, that first of all it has got 1 which could be stressed, plus the row of 1 is equals to the column of the other. That means we can easily stretch the value. So these value will be stretched, and that's our result. So this will be stretched towards the minimum value. In this case, what is the minimum side? Minimum side is on the row side. So this will be broadcasted, this will be broadcasted and it will extend to create 3 more rows to match with this particular value, and accordingly your both the data will be added to give you the resultant output. So this one will be stretched, this particular B part will be stretched here. A will remain as it is. There will be no change in the A side, no requirement of a stretching, no requirement of broadcasting. So B is broadcasted here on the smaller side. B array is broadcasted on smaller side. So in the smaller side, that means this one row side here, and then they are being added here, A plus B. That will give you the answer. All right. Now let's generate a random integer. To generate a random integer, we have got random.randint. Random.integer is there. You can provide a shape. Randint is there. Random integer will be generated. Again, same. You can do here the B part. B dot ones. Let's try to do it. Let's try to do here the same value. So if I'll do A plus B, let's do A plus B here. So 1 will be added to all the value again by the help of broadcasting. If you wish, you can reshape the B, right? If you will see the current shape, it will show only 5. But if you wanted to actually reshape it like 5 cross 1, you can do that one as well. So let me actually reshape it as 1 cross 5. That will also do the same thing. But in this case now, it will be broadcasted towards your column side. Towards your row side here. The smaller side will be always broadcasted, remember it. So even if you will reshape it to 5 cross 1, suppose I'll do it for 5 cross 1, then what happens in that case? Still, it is same. You will get 1 will be still added here. Okay, wait a second. New value needs to get updated, right? So, okay. Now let me try here. Now this is not possible. It is not possible here because the shape is mismatched. 3 cross 1 is fine, but 5 cross 1 could not be stretched. 5 cross 1 could not be stretched. If you will write here 1 cross 5, just write here 1 cross 5, and you will try to do it, this is okay. No problem in this. This particular part is fine. But as soon as you will do 5 cross 1, this will give you the error, and error will be shape mismatch. So not all the possibilities are there. I mean, you have to look for whether the possibility is there or not in the broadcasting, and accordingly your array will be responding. So I'll give you the error part now as well. When we do this 5 cross 1, that will generate the new shape. So in order to do this one, that means we should have at least 5 rows. which is not available in our this case. So either this should be reshaped to 5 cross 3, then it is possible. 5 cross 1 is not possible because our number of rows and this could not be broadcasted here, right? In order to do this one, that means we should have 5 entries in this rows. We don't have the 5 rows, right? How it will be stretched? This will be stretched towards this direction, correct? 5 cross 1 means this one, 4 cross 1, correct? But we don't have a value that should match on this side. We don't have that value, correct? Why? Because the shape is 3 cross 5. So either we should have a shape of, in this case, either we should have a shape of 5 cross 3, that is okay. So we should have a 5 rows, at least in this case, which is not there. That's why. Let's do the A plus B here. And you will say that the shape is mismatched. So you need to change the shape of this, then only A plus B will be possible. So you should know the values which are possible and the values which are not possible here. Yes, it can be broadcasted only in one direction, on the smaller side. It can be only broadcasted towards the smaller side. So this particular thing could be broadcasted towards this smaller side. What is the smaller side here? 1. So only this position, only at this position it can be broadcasted. Okay. Now I'll discuss about the transpose part. Next part is transpose. That will be the end of last section, I guess. This is the last portion. In order to work with the transpose, that means our shape will be transformed. Currently the shape is 5 cross 3. Currently the shape is 5 cross 3. Let's take the shape. A cross shape, you will see 5 cross 3. If you wanted to convert the shape, you wanted to do the transpose, means it will swap the order of the axes. Transpose swaps the order of axes. In this case, the axis has got the shape of 5 cross 3, so it will be changed to, when you write A cross T, the new shape will be 3 cross 5. 3 cross 5. This is useful in matrix multiplication part. If your shape is mismatched, then we can take the transpose of the value. We can take the transpose of the value. In order to match the number of rows equals to number of column rule, if you wanted to do the multiplication. Next is flattening the array. Flatten. Next, some of the structural functions are there. Just using here flatten. Next function is flatten. Flatten means, suppose we have got the same array, I'll take the same. You can also use np.transpose, yes. np.transpose you can also do, or you can do here a.t. Generally we use .t here, which basically will transpose your value. Okay, and now this is my new shape here. What does this flatten does is it will convert your multi-dimensional array into a single dimensional array. Flatten. From multi-dimensional it was a 2D array. Flatten has converted into 1D. Flatten converts multi-dimensional, or you can say ND array, to 1D array. Flatten converts 1D array to 1D array to sorry ND array to 1D array. You can have a matrix of matrix as well. Suppose the shape of this array is 2 cross 3 cross 3. That's the shape. 2 cross 3 cross 3. You can also apply here, in this case also you can apply the flatten, and this will particularly convert them into a single dimensional array, so each value will be filled with your array part. A dot flatten. This will also do the same thing. So that's what the flatten does here. Okay, exercise number, finish our things. Suppose we have one array. Okay, this could be applied to your 2D array, 3D array as well. In that 1D array, we have got all the elements. I wanted to target these elements which falls between value 3 and 8. Okay. Now between these two values, whatever the values are available, I wanted to replace it with its negative value. So that's what called as negating the elements. Negating the elements means it will particularly convert, it will replace the value with its negative. So in case we have got a here again, a equals to np dot arrange, and we'll provide here 15. Let's say this is my value. 15 elements are there starting with 0 to 14. So what I'll do here is that I want the value which falls between 3 and 8. I will target it, and that those particular value which falls between 3 and 8, it should be replacing it with a negative of the value. It should be replacing it with a negative of the value. It should be replacing it with its negative value. Okay, go ahead. Okay, try it out. How to particularly target those index positions which falls between a value of 3 and 8. How does we do it? And those particular position, I wanted to replace it by its negative. Okay, try it. This will be the last part definitely. So we'll end at exercise number 3. Try by any means. I want the answer. Okay, so I got few of them. Let's get started. We got here my array value. Okay. My question is that I wanted to negotiate all the value which falls between 3 and 8. I think 3 and 8 means I'm not interested in getting the index position of it, but the by the value. In case if these are available in this way, that doesn't mean that you will particularly write the index position. That was not my intention here. My question was that I'll just particularly write here a greater than 3. Fall between 3 and 8, so I'll not consider a here and it will be returning your true and false. This is your array. A is your array here. Don't get confused. ARR, ARR. So ARR greater than 3. Whereas where we are getting true and true and true. Okay. Next I'll write and I'll just say that okay, let's make it as smaller than 0, smaller than 8. That will be particularly falling between 3 and 8 here. Will just fall between this. Alright. That's how we filter the value. Now these particular specific position where we are getting true and false, that needs to be replaced by your array of n, and this should be replaced by your -1. Okay, that is your array. 5, 4, 5, 6, 7, these are all negative here. I have multiplied here, I have not added here. Multiplied means whatever the existing value is there, it will be replaced by its negative. That's the end of your. I think a few of you have given the correct answer as well. But most of you have given and considered it as a index position. So index position was not the point here, it was about the value. So when we talk about the value, we just write it like this. And that's the end of your today's session, this week's session, and your NumPy as well. You can try some exercises here. Whatever is available in your PPTs, you can try them in the in the upcoming week. In the next weekend, we will start with our pandas, and we will also discuss about the very important statistics part will also start. So that's the story for the next week. Try NumPy and try a lot of questions here. These are just 3 exercises to give you some tests. Hopefully, you have been understood all these points about the NumPy today. When I slow down a bit in the later half because many of you were, I think, were not able to catch. So anyway, we'll try to speed up in our upcoming session. Once we are done with the basics, then maybe you will able to. But yes, what I have miss out here is that you guys, many of you are asking the same question, which we have already learned. So repeat it, whatever we learn, and that's how this could be done. So complete everybody. That's it for today's session. Thank you so much everybody for joining today's lecture. This is the slowest speed that we can go. I mean, we are having so many topics to cover. So you have to go and expect our speed to get increased. That's why we are having the video. Nobody is asking you to match with my speed. Watch the video multiple times, and non-programmers have to obviously put an extra effort. Watch our videos, practice it again, watch our video and again practice it. Day 1, day 2, day 3, day 4. All these you have to keep on repeating and repeating so that you can understand it. The more you will practice, the better you will become, especially for the non-programmers background or non-IT backgrounds. Right, the dry part is still under the review. It's still not been revoked. I'm also waiting for that. That will make my things smaller. Where you should practice. See, first of all, in every lesson, by the end of every chapter, you'll find some exercises which will